Hi everyone, this is Sairaj from AIML second year, and my topic is current use of Linux in spacecraft flight software. Let's enter into topic. First, introduction. Spacecraft on board computers are responsible for controlling the spacecraft platform, payloads, or other onboard devices. Their mission specified software allows communication with ground or other onboard computer traditionally. Onboard computer software has been written close to the hardware in assembly language, ADA, C or C++ with or without a real-time operating system. As the spacecraft computer hardware capabilities are increasing, spacecraft software is becoming larger and more complex, handling more tasks from payload data processing to landing a first stage of a launch vehicle on a ocean ongoing barrage. Spacecraft will still continue to include very small embedded systems that can be developed without operating system OS, but some systems will also have larger software base requiring efficient software development process and reuse of existing software modules. Here, spacecraft onboard computers. Spacecraft onboard computers are responsible for handling telecommands sent by ground, providing telemetry to the ground, processing onboard data, and controlling the spacecraft platform and payload device. A spacecraft may have one or several onboard computers that handle different tasks. Similar to other embedded computers, a spacecraft onboard computer usually had at least a processor, random access memory, read only memory for boot code, mass memory, database interface, and a power supply. Perhaps, unlike many other embedded computers, some parts of the onboard computers may be made redundant to circumvent any possible hardware malfunctions. According to ICHUP's radiation hardened space power PC MIPS and Intel x86 architecture have been popular in traditionally industrial and government space application. University small satellite missions have tended to use a larger variety of processors, especially from the ARM family. According to a 2010 analysis, low power microcontrollers such as the microchips PIC series and the Texas Instruments MSP series have been popularly in CubeSats before 2010, while ARM microcontrollers were becoming more popular due to their great processing power. Some inexpensive commercial off the shelf, that is COTS controllers such as the Texas Instruments Hercules family have safety critical features previously usually seen in expensive high reliability process, making them attractive for space applications. Spacecraft onboard software. The onboard software running on the onboard computer responsible for utilizing the computer's hardware resource and interface to achieve specified missions such as controlling the spacecraft or some platforms or payload instruments. Onboard software must typically provide at least a telecommand and telemetry interface that is utilized by ground control or some other onboard software running on other onboard computer. Onboard software can be roughly divided into three parts that are hardware drive software for providing abstraction of the underlying hardwares, OS for providing task and resource management, and application software for providing the mission specific functionality. This division is some of simple onboard software may not be need an OS at all. The hardware driver software is usually provided by the hardware manufacturer as a software abstraction of their hardware, and various users of the hardware in different industrial domains may use the same driver software. The OS is an optional component, and in many cases it has not been used at all. In some cases, the OS itself may provide the abstraction of software intent of separate hardware drivers software historically. Much of software flight software was written from ground up using assembly language, ADA programming language, which has long had advanced task features, has been used to build onboard software systems running several threads of execution. However, recently the use of ADA has been reduced in favor of using real-time OS along with C and C++ programming language due to the larger availability of developers for this language. When most of the software has been written from scratch, the end result had tended to be very tightly coupled and not well suited for later use in the other projects. When OS has been used in spacecraft, common selection have included VxWorks and Artemis, but VxWorks and Artemis are RTOS designed for embedded systems and commonly used in safety critical hard real-time application. University small satellite missions have also used other general purpose RTOS such as free RTOS. Here we can see some of the benefits using of Linux. And first one, the benefit of using Linux in spacecraft flight software are similar to those for embedded system in general. Homer and Hallian have identified the following benefits for using Linux in embedded system. Support for many hardware architectures, perhaps widest support by any OS, allow freedom in selection of the hardware platform. Linux code base can be relied upon due to its very wide adoption and availability of source code, allows verifying correctness and correcting found problem without delay. Support for many communication protocols and standards make interfacing with external device easy. Availability of standardized development tools, for example, for the GNU project. Larger developer community provides supports and developer recruitment full possibility of vendor independence, open source license, and low cost of adoption. Furthermore, Pirani et al. Have found more specific benefits of using Linux in spacecraft flight software. Optional soft real-time capability parts of software can be developed and debugged on desktop Linux computers and ported to flight environment with little effort. Existence of huge catalogs of Linux software from various industries that can be taken into use in the flight computer with little effort, including data compression, file systems, operations, scheduling, data processing, security related software, algorithm, and scripting. Linux has many useful general purpose facilities available such as file systems, database interface, process scheduling, and interprocess communication. The POSIX abstraction has existed for decades, and most POSIX compact compatible software can be made to run on the embedded Linux system. Generic spacecraft software module handling, for example, attitude control targeting Linux, should be written and distributed commercially or non-commercially across projects. As mentioned, SpaceX has reused this same software in their launch vehicle and orbital spacecraft. Linux could thus make it easier to produce hardware independent software system. Shell scripting in Linux can be substituted onboard control procedure that are traditionally used to automate spacecraft operation. This approach was used for example in TechSat. Yes, here the conclusion. It was found that Linux has several benefits for spacecraft software development, including availability of source code and development tools, larger user community, and pool of developer development across several industries, that leading to off-the-shelf availability of many utilities and software and support for many types of hardware. Platform independent Linux targeted software could even be developed and used across various machines. However, before Linux is to be used, questions that need to be considered, including limiting hardware selection mostly to 32-bit and 64-bit architectures, uncertain and unstandardized hard real-time capabilities, and the possible presence of unused software modules that only consumes resources without additional values. It is likely that the use of Linux in all kind of soft spacecraft will continue to grow. SpaceX and Planet have already commercially proven that Linux can be used equally well in all categories of spacecraft, launch vehicles, CubeSats, and in the further mannered spacecraft. Thus, Linux software could be traded between spacecraft and everything terrent terrestrial. Development for Linux can also be taken into space with very little effort. The popularity of Linux is possibly one of the greatest reason why it will continue to be take to space. Thank you everyone.